Hey guys, this is my first machine learning project made in Unity. As you can see, the blue character is a self-trained AI, which after training itself for 20, 15 to 20 minutes, it has learned to evade the bullet. It's still not perfect. The more time the training happens, the more intelligent the AI will be. So this is amazing because it uses very minimal coding and it has basically self-learned it has self-learned the environment and it's behaving on its own. There's no behavior trees, state models, or anything of that sort. So what it does is it uses a training environment, which I'll show you. This environment is where the agent trained itself many times to arrive at the intelligence of the game, uh, which is present here. After that training, we get a NN model file, uh, which the agent uses to navigate in the world. I've updated the GitHub link in the bio. So in the next few videos, I'll brief you guys on how the project is set up and skim through the code and explain them too. Thank you. Okay. First open Unity. So I'm using Unity 2019.1.1 F1. Now in order to use ML agents, you need to clone the ML agent project or you can get the archive. I've got the archive from this site, so I just downloaded the zip. Now you download the zip and then you just drag and drop it into the project here. So this is the ML agents package. So I've already set up the scene. So it contains a ball, a player, and six spawner points where the ball will spawn around on. And note that every every scene which has a agent, like the player agent, right, the ML agent, it should have a academy. So this is the academy which I've used. So an academy contains all the agents objects in a Unity scene. Every scene containing agents must contain a single academy. So you need to create an empty game object and just attach the script to this particular game object. That's and also now if you see the player, right, this is the player. So we need to attach a player agent script. So I've created a class called player agent and then attach the script. So once you attach the player agent script, if it inherits from an agent class, automatically the behavior parameters will get updated. I'll explain you about this in the next video. But for now, you just need to understand that if this is the agent where you attach the player agent script, and once you do that, the ML will basically work on this particular player. So machine learning is based on this player. So basically now this is called an agent. An agent is an actor that can observe its environment and decide the best course of action during those observation. Now let's look into the player agent class. So the player agent script needs to be attached to the player game object. So the player agent inherits from an agent class. So once you do that, automatically a behavior parameter script will be attached to the player game object. This behavior parameter script is nothing but the brain of the particular agent. So it has a model which is the learning, which has a learning model which helps the player move around. So this is like the brain. Coming to the player agent class, so one of the main methods used here are to know are collect observation method, agent action method, heuristic method, and agent reset method. So collect observation method is nothing but it helps the agent observe this particular method helps the agent observe its environment in order to understand the state of the world. So there are two kinds of observations. There is like a vector observation and a visual observation. In my project, I have used only vector observation. It's a quick way to do observations, and a visual observation is nothing but it uses a camera. So there are two observations being made in my project. So I get the distance between the player agent and the bullet, and also the angle between them. So using these two observations, the agent intelligently learns how to dodge a bullet. So if it collides with the bullet, it will understand it. Okay, the bullet is near me, so I need to stay away from the bullet. That's how it learns, and that's what we need to do in collect observation methods. So yeah. So in agent action method, before coming to the agent action method, let me look at the heuristic method. So heuristic method. So if you check in this checkbox like use heuristic, right? So what happens is the user will have control of the game object. So let me just show you. So I do use heuristic and then I play. So I'm basically controlling the player now. So use heuristic method returns an array of floating point numbers. So for every key press, I'm just giving a unique number to it. So 1, 2, 3, or 4. So yeah. So if you have to have another action for jump, right? So you can just give, if key press is jump, you can add another array. So if you press space, it's 0. Otherwise, it's 1. But for now, mine is only left, right, up and down. So I just use four numbers of one floating point array. Okay. So if you don't check in use heuristic, so there's an agent action method. So what the agent action method does is it gets the vector action of 0. So vector action of 0 is nothing but if I have checked in heuristic, it's just this number 1, 2, 3, or 4. If I press A, W, or if I've not checked in heuristic, then that means this is the vector action method, vector action of 0. So it gets the branch 0 size. So there are up to like 6. I've just given it like there are 6 ways the agent can move. So it picks up one of those ways and then it moves accordingly. So that's how it is. So when I give the vector action of 0, it gets the movement, and then you move, and then if it is 1, I move to the left. If it is 2, I move to the right. 3 up, and 4 down. So this new movement, so this is the grid script which calls the move class, and it has the new movement variable. So this new movement is the cells of transform. So our player agent will be transformed to that particular cell. Cells is nothing but the game object, array of game object, which is nothing but these four movement grids which are invisible. So it jumps to that position according to my button press. So if okay, that's how the movement is done. And then you after so we have a agent reset. So once you collide with the bullet, that means if you have checked in reset on done, that means the agent will be reset to the cell's third cell's position, and then you spawn the bullet again. And then when the agent is getting collided with the bullet, right, you just have this method called add reward. So this basically tells the agent that you are colliding with the bullet. That means I have to take away reward points from you. And then the agent learns, okay, so I should try to avoid the bullet in order to gain reward. That is what I have given here. So when I've successfully dodged it, I just gain the reward. And once it's done, that's how the agent keeps learning. If it gets a positive value, it means like it's doing well, and it keeps learning from that. So it gets a positive value, and it checks the position of the bullet and itself and the angle between them, and makes note of it. Okay, this is how I'll be successful, this is how I'm not successful. That's how it learns. Coming to the player game object. So you have the behavior parameter which I told, right? So vector observation. So I gave the space size as 6. What is the space size? So in add vector obs, I have given these two. This is a vector with three values, vector 3 value, and this is 3. So 3 plus 3 6. So that's how I give as 6. Once you have more number, you can just more number of observations. You might miscalculate your value. So you can whenever you press play, you'll get an error saying that the space size is not coinciding with this. So you can just change the space size at that time. And the vector action is nothing but the action which needs to take, whether it has to go up, down, left, or right. If this is the vector action which I told you about, this floating point number array. Okay, so in this video I'll be telling about the rest of the scripts, that is the bullet script, the destroyer script, spawn manager, and the stone academy. So let's start with Stone Academy. So the Stone Academy script has a Stone Academy class. So Stone Academy class is, so this is like I told you, right? The academy, whenever you have a agent in the scene, you need to have an academy. It's like a training environment for the agent, the particular academy. So in Stone Academy, I have a academy reset class which is overridden. So once the level resets, right, this particular class is called. So what this does is like the bullet speed will be set back to normal. So it will be reset. So if you give reset parameter of bullet speed, if you go check here, it has a bullet speed and it will be reset to a particular value. That's what this does. And then this manager, and this is the bullet speed which it gets the value from here. Whenever you change a value here, it gets the value from here, and then it assigns to the spawn manager class. Now coming to the spawn manager class. So spawn manager is nothing but it spawns the bullet every place, like at these 6 points, 8 points. So it has a bullet speed. So this bullet speed will be set here, and then it spawns the bullet. So what happens is it takes a random number between those six. So it takes a random number using the random dot range, and then it gets the particular spawn points index position we'll get the position, and then we'll assign it, and then this will be assigned to the bullet. So this is how basically you are just taking the bullet from one place and then moving it to, like, setting it to another place. It's as simple as that. So after that, you assign the speed and everything which is already set. So the next class is the bullet class. So the bullet class script will be attached to the bullet game object here. This is a bullet game object, and you attach the bullet script. It has a manager, player, a destroyer. A destroyer is nothing but these cubes. So it has 4 destroyers. So once the bullet reaches this particular destroyer, it gets reset to another spawn point. So that's what's happening here. So if you go to the bullet class, right, you get the transform Z position, you check the position of the bullet, and then you check the position of the destroyer. If it crosses it, you just tell that the player agent has successfully dodged it. When you do successfully dodged, the reward is added here, and then you spawn the bullet again. That means you take a position out of this and then reassign it. So it's basically recycling it. You take it here, you just recycle to another point. That's what's happening. And on trigger, this is on trigger enter. So I've just made 2 checks. So one is the position. If the collision doesn't work, then I go to the position. So here, if I check if if the tag is destroyer, so that is the one of these. So I've given the tag destroyer. If it is destroyer, I successfully dodge it and then spawn the bullet to another place. That's basically what these classes do, simple classes. So that's it. Okay, let's get started with scripting now. So let's have a, for the player, we need movement for the player, right? So let's have a class called grid movement class. I've attached the grid movement script to this particular player. So basically the movement works this way. So let me show you. So from this diagram, we have 4 square positions where the player will be able to move. So this is equal to, like, the positions which I have given here are similar. So I've hit this particular game objects, but these are basically where the player will be jumping around on. The second one, got it? Okay. So we will have a vertical movement and a horizontal movement, and also we assign a number to each square. So for, as you can see, this is 0, 1, 2, 3. So we need to allow the player to jump across this square. So there will be either a vertical movement or a horizontal movement. Okay, let me go through the code now. So we have a enum called direction, which shows like up, down, left and right, which basically signifies vertical or a horizontal movement. And then we have two private variables called vertical movement and horizontal movement and a current number. So initial position will be considered as like we think let's consider the player will be at this particular position. So this is bottom right. So vertical movement, we'll consider that it has gone down currently, and horizontal is it's at the right. And we assign the current number as 3. So in the movement script, it's basically like we get a direction, we get a arrow press. This will be coming from the agent class, the player agent, which I just told you, right? So the player agent class, it will get a movement and it will call this particular method. So we need to check. So when we press left, what happens? So you are here, you press left, you go here. Similarly, you are here, you press left, you go here. So what happens? Then the current number will from 3, it goes to 2. Similarly, from 1, it goes to 0. And what is the vertical movement? It's left because you are moving towards the left. And horizontal movement will remain the same. So that's what I have given here. So horizontal, so when you are, sorry, I mistook vertical and horizontal. So horizontal movement will be changed to left. So when you think that the left direction was pressed, so horizontal movement will be updated, the current number is reduced by 1, and then you just return the current number where the uh, number is. And I'll explain you the player agent class and how this works there, but just get an idea of how the movement works on. Similarly for right, so the horizontal movement will be this way. So it will be right, and then what happens when it's at 0 and you press right, you go here, it becomes 1. And when you are here, you press right, it goes here and it becomes 3. That's the reason what I'm doing is I'm updating the current number to 1 by 1. So if it's 0, it becomes 1. If it's 2, it becomes 3. Similarly, let's take the up direction. So when you are here and you press up, what happens? This becomes 1, right? 3 minus 2 is 1. And you are here and you press up, it becomes 0. So we update the vertical movement to be up, and then we reduce the current number to 2, and then just return it. Similarly for down, you are here, you press down, adds 2. You are here, you press down, adds 2. So you just get that, and then you return the current number. If none of this works, then you return minus 1. Now, let's consider a case where the character will be present here. So what will happen at that time? If we press left, the index currently the index will go out of bound, 0 minus 1. So when you press left, it becomes minus 1, right? It will go out of bound. Similarly, when you are here and you press right, that's fine, it goes here. But when you are at 3 and you press right, what happens? It goes to 4 because you are adding current number by 1. So this edge case has to be handled. So for that, what I'm doing for handling the edge case is, suppose when I get a direction which is equal to the previous direction. For example, you were here, you press left, it becomes 2, and you press left again. But it's so the previous movement is horizontal movement is left, and you press left again, then you just return nothing. You return minus 1, telling that the player can't move. You just stay there. That's what I've been doing here. Similarly, vertical movement, right? When you are here, you press down, it becomes 5. So when you're here and you press down, the vertical movement will be added to, and then it will be down. And when you get an arrow press of down again, it will prevent it from doing it. So that is what this script does, this particular block. So yeah, this is basically how the grid movement is. It's pretty straightforward. It's pretty simple.